Welcome to RaWMachines, the journey to discover the most impressive processes around the world. Today, let's go deep into a job that seems rough but demands absolute precision. Hanging grindstones and grinding saw blades in the traditional grinding workshops of the Bergische Land region. This is where stone, water, and human strength operate together in a system that has existed for centuries. Let's get started right now. Grindstones were not born in the Bergische Land. They came from the Eifel region. The sandstone here has an ideal granular structure, hard enough to bite into steel, yet soft enough not to overheat the saw blades. Around 1900, the Remscheid tool industry alone required 2,000 stones per year. That is a staggering figure when one considers that each stone could weigh from several hundred kilograms to several tons. The giant circular stone blocks were loaded onto flatbed wagons, secured by wooden stakes through the axle holes. The technical limit of the railway, 3.04 meters, determined the maximum size of the stone, a small detail that governed the entire design of the grinding workshops. After World War II, the stone trains became infrequent. By 1971, only a few wagons remained each year. But in the memories of the grinders, the journey of the stone was still a ritual, from the rocky mountains of the Eifel to the water valleys of the Wupper. Between the quarry and the grinding workshop stood a very special intermediary, the millstone dealer. They didn't just trade stone, they evaluated it. Every crack, every grain structure was inspected and classified according to the exact task the stone would eventually serve. A single warehouse could hold up to 400 stones, and each one carried a different future. Knives required hard stone. Surface grinding demanded softer stone. Saws, hoes, files. Each tool posed its own technical challenge. Choose the wrong stone, and the product would be rejected. Worse still, the reputation of an entire workshop could collapse. At the time these films were captured, 2 grinding workshops in Remscheid still utilized natural stone. This type of stone provided an exceptionally smooth finish, but it also caused silicosis. the disease that stole the breath of generations of grinders. In 1930, these stones were officially banned. However, the law always lagged behind reality. It was only after 1950, when synthetic stones and replacement machinery were truly ready, that the ban was strictly enforced. Wolf and Bangert originated from water-powered hammer mills along the streams. Initially, grinders worked as independent contractors, taking on work on a piece rate basis. It was not until 1923 that the enterprise decided to install its own grinding benches, bringing the grinding work into internal production. This was a step aimed at breaking the traditional monopoly of the grinders and controlling quality more strictly. But it also lost some of the freedom of those traditional craftsmen. Replacing a grindstone does not begin the moment it stops spinning, but from silent preparations that take place long before. Spare stones are always positioned in front of the door, not just for convenience, but to remind the craftsman that a stone must never be allowed to fail unexpectedly. Grindstones are highly sensitive to frost. If frozen, micro cracks can develop inside. These cracks are nearly invisible to the eye, but become extremely dangerous when the stone rotates at high speeds. Consequently, the timing for replacing a stone is chosen not based on production demands, but according to natural conditions. Inside the grinding workshop, there is a vast array of equipment, testifying to the continuous development of modern technology. Prominent among them is the ply machine, which uses sprinkled corundum sand to polish the surface. At the end of the workshop is the old trough grinding bench for natural stones, currently in the process of replacement. The old grindstone has worn down to a diameter of only 1.20 meters and has just been removed to make way for a new stone measuring 2.53 meters, capable of operating for 3 to 4 weeks. Beneath the grinding bench, the thick layer of accumulated grinding sludge has now been cleared away. The bottom of the trough is lined with sturdy wooden blocks, ready to support the stone as it is lowered into the pit. The top press stone, which suffers almost no wear, remains in place and has a lifespan far exceeding that of the large grindstones. Every stage is coordinated by the hammer mill carpenter, from measuring to arranging the wooden beams, so that the stone's axle hole sits higher than the edge of the trough. Previously, to reduce the impact force, They did not use pine branches, but instead used tightly bound bundles of twigs. Lowering the stone does not involve modern machinery. Everything relies on wooden beams, steel rollers, crowbars, and winches. When the stone reaches the edge of the pit, the operation becomes particularly dangerous. The rear part is slightly lifted, allowing the stone to tilt gradually downward at a pre-calculated angle. Water is continuously poured onto the stone's surface to reduce friction and limit the risk of chipping. Throughout this process, the weight of the stone remains in a suspended state between the support points. If a roller slips, a wooden beam cracks, or the winch cable slackens, consequences can occur instantly. There have been cases where the stone struck the pit wall with force, necessitating it be ground down smaller or worse, causing severe injury to those standing nearby. When the stone finally lies still in the pit, no one is in a hurry to breathe a sigh of relief. It is not yet secured, the axle is not yet attached, and it has not yet proven that it is obedient enough to serve humans. But that moment marks an important turning point. The stone is in its proper place, and from here on, its fate will be tied to the rhythm of rotation, the sound of water, and the grinding work spanning many years thereafter. Now comes the stage of axle installation and balancing, a test of experience and patience. The iron axle is inserted first. It is a long, heavy metal block threaded through the central hole of the stone. On both sides of the axle are large spacer discs, whose task is to keep the stone from shifting left or right during rotation. In the memories of the old craftsmen, there was a time when oak axles were used. Newly felled wood, still damp, was thought to be suitable for the watery environment. However, as the wood dried, it expanded unevenly, creating pressure on the stone's hull and causing catastrophic stone explosions. Since then, the iron axle has become an irreplaceable standard. Balancing is the most time-consuming part. The stone is test rotated by hand slowly to observe heavy and light points. Chalk is used to mark eccentric spots. Each small adjustment is made, sometimes involving only a very small part of the rim, but it can determine the entire stability when the stone reaches high speeds. When the stone finally spins smoothly, without wobbling or vibrating, the craftsmen know they have finished the hardest part of the work. The stone is now tamed, ready to enter the next challenge. The craftsman uses a hammer to tap lightly on the body of the stone. The sound emitted must be clear, resonant, and even to be up to standard. A dull, hoarse, or intermittent sound is a sign of an internal crack. If the stone passes this step, the test run begins. The stone is allowed to rotate slowly, just enough to check the initial reaction. After that, the speed is increased step by step to approximately 15 seconds. The observation lasts continuously for about half an hour. The craftsman does not only look at the stone, but also listens. An unusual vibration, a strange howl of the wind, or a small change in sound could all be signs of imbalance. In such a case, the stone will be stopped immediately for re-inspection. The history of grinding workshops is not lacking in stories of stones breaking. Centrifugal force can tear a stone apart in just a moment, turning it into deadly flying shards. Therefore, caution during this stage is never redundant. All craftsmen must stand far away from the stone. If no damage appears after 30 minutes, the test run can conclude. The work now shifts to another stage that is both brutal and delicate: scoring the stone. The scoring tool is an iron bar about 1.5 meters long with a hardened tip. The craftsman stands slightly to one side, holding the bar with both hands, slowly applying it to the surface of the stone, rotating at half its working speed. As soon as the iron bar touches the stone dust shoots out thickly, covering the workshop space. A piercing scratching sound rings out continuously, signaling that the stone surface is being shaved layer by layer. Due to the high level of danger, the scoring process is usually handled by a single skilled craftsman. Others stand outside the area, observing from a distance. There is no room for experimentation or apprenticeship. Every movement relies on experience accumulated over many years, sensed by hand and ear more than by eye. This chapter closes as the stone dust settles. The stone is ready for its real work. And from here, the relationship between stone and steel officially begins. First is the installation of protective guards. The front of the grinding bench is covered by a sturdy shield, sufficient to stop stone or steel fragments from flying out in case of an accident. Below, thick sacks are hung to catch splashing water and grinding sludge, preventing the work area from becoming dangerously slippery. Once the protection system is complete, the grinding trough is brought into synchronized operation. The grindstone rotates rapidly, handling the removal of steel, while the pressed stone rotates more slowly, keeping the workpiece stable and controlling the pressure. An even and steady grinding sound indicates that the stone has got to work. From that moment, it is no longer just a newly installed block of material, but becomes a living part of the grinding workshop, directly participating in the production chain. At Wolf and Bangert, grinding isn't simply a matter of steel touching stone. It's a sequence of refined actions in which the grinder's body becomes part of the machine itself. Two techniques best illustrate this: knee grinding and flat grinding saw blades. Knee grinding, Knieschleifen, is the oldest and most personal method. The craftsman works alone, kneeling or bracing a knee against the pressure mechanism, using his own body weight to control how firmly the workpiece presses against the stone. It's slow and physically demanding, but it allows an extraordinary level of control. For specialized tools or fine work, knee grinding is still considered the best way to read the interaction between steel and stone in real time. Flat grinding saw blades is a different story altogether. Saw blades are long, thin, and prone to distortion, which means the grinding surface must be perfectly even. Before any real grinding begins, the craftsman often uses a scrap blade to dress the stone, cleaning and stabilizing its surface. During grinding, each blade may lose up to about 0.7 millimeters of thickness. Water is supplied continuously to cool the blade and prevent excess heat that could reduce the steel's hardness. Once grinding is complete, the blade is immediately immersed in an anti-rust solution. It's a small but crucial step because freshly ground steel is highly sensitive to moisture. Just a few minutes of delay can be enough for the first signs of rust to appear. Two techniques, two very different rhythms of work, yet they share one thing in common. Total responsibility rests in the hands of the craftsman. Here, machines don't replace people. They demand that people understand material, motion, and the limits of their own bodies more deeply than ever. The debate between natural grindstones and artificial ones has never truly ended. Artificial stones, made from corundum or magnesite, have advantages in uniformity and ease of production. But when used for fine grinding, especially thin saw blades, they generate high heat and leave a coarse grind mark. The steel easily loses its hardness, the surface rusts quickly, and it often fails to meet customer requirements. In contrast, natural sandstone from Neidenbach provides a finer and gentler grind line. The stone bites into the steel evenly, generates less heat, and is easier to control by the craftsman's hand. It is this very difference that causes many workshops, despite being under regulatory pressure, to return to using natural stone for products requiring high quality. This is not nostalgia, but a choice based on practical quality. This film concludes not with a new invention, nor with the replacement by modern machinery. It closes with a rotation that still continues, the grindstone spinning in water, steel touching stone, and humans standing at just enough distance to work without losing respect for the danger. Throughout that journey, the stone is never an inanimate object. It reacts, resists, sometimes destroys, and only agrees to cooperate when placed in the right spot, in the right way, and treated with absolute respect. The grinder, therefore, is not merely a machine operator, but a person in dialogue with the stone, someone who understands the stone down to the smallest detail. In the modern industrial world, where speed and output are often prioritized, The traditional grinding workshop reminds us that quality sometimes comes from accepting to slow down. Natural stone is uneven, human strength is imperfect, but it is that very imperfection that forces humans to observe, listen, and adjust constantly. Skill does not reside in the machine, but in the body and experience. The saw blades leaving the grinding workshop are not just industrial products. They carry the traces of water, stone, oak, and the hands that accepted working in a wet, dusty, and high-risk environment. Each grind line is a successful compromise between rigid material and a human who knows their limits. As the stone spins steadily and the workshop returns to its familiar rhythm of labor, no moment of victory is declared. This trade does not create heroes. It only creates craftsmen who know how to repeat their work precisely, day after day. And it is within that repetition that a tradition is preserved. The film ends, but the rotation does not stop. Somewhere in the valley, water still flows, the stone still spins, and humans still stand between them, not to conquer, but to work together, in a fragile balance that has existed for centuries. Thank you for listening to the end of the story. If you also enjoy similar videos, please press the like button, share, and subscribe to the channel so you don't miss any interesting stories next. RaWMachines says goodbye and see you again.